to go?
Yeah.
It's recording.
Okay. Okay, I hope we're all set. Okay. Welcome, everybody. So I'm going to give an update about the latest features in CPS, do a quick demo of that as well. I hope to be interactive, so especially during the demo, feel free to ask questions and I can maybe demonstrate more things that you'd like to see. Okay, for those who don't know me, my name is Tom Siebelink. I'm a master engineer. I've been working over 20 years in Ericsson. I've been working in the open source ONAP project since 2020 as the project technical lead for the configuration persistence service. My focus in any project has always been on quality testware and quality software. I deliberately put them in that order because I think quality testware will automatically lead to quality software. Performance has also been a passion of mine. I'm very proud that the CPS project recently has achieved the OpenSSF Gold Badge for best practices and is related to quality and security. Okay, so the agenda for today, I'm going to give a quick recap of the CPS concepts. As Björn already mentioned, we want to try to reuse ONAP components in a more generic way. So I'm going to go back a little bit to basics for people that are new to it and maybe find a completely different use, even a non-telecoms use for, and that would be possible for CPS. I'm going to demo the Delta feature. So this was something that Florian mentioned that in Deutsche Telekom, they're particularly interested in this feature and they hope to use it in production next year, as he mentioned. Then I'm going to go into some performance improvements in something what we call micro benchmarking. During the performance improvement, we learned something, and I've been developing Java for 20 years, and I didn't know about this. Literally in the last couple of weeks, I learned about this warm-up effect, so I'm going to share some of that information with you guys. And then I'm going to show you how we monitor performance now on kind of for the long term in CPS. Okay, so let's start with CPS concepts. So this is from an early presentation I did on CPS. So CPS is designed to store any young model data. As most of you will know, young models are, and on the left here we have like an example of a young model. And then on the right, we have an instance of data in JSON. Data can also be in XML format. But the idea is, of course, that the model describes the data. And then in Young, we talk about data trees. Actually, the CPS logo is based on this idea of a data tree. And trees have like branches and they have leaves, which are typically the properties of your data. And we plant a tree in something what we call an anchor. So that's like a placeholder where we plant a tree. We also talk about data spaces. So a data space is like a ring-fenced area where somebody owns it and they control access to it. They control what kind of trees can be planted there. So the trees are described by these young models that I described earlier. So they will describe the types of trees. You can think of that just to kind of push that allegory. So any application can define their own data space name and kind of maintain it and is responsible for it and for the models that it can contain. Okay, so kind of straight into a demo now of some of these core fields. Sorry, I'm going to demo the Delta feature. Sorry, no, apologies, got a little bit off track there. Let me explain a little bit about the Delta feature first. So the Delta feature is a community-initiated contribution. It's about comparing the data in different anchors. So the context here is that a customer stores configuration management snapshots over time. And they also have planned configuration changes stored, and they like to compare these. So what are the kind of use cases? You can compare plan changes with recent snapshots. How do they compare? What has changed? You can see the impact of any proposed configuration plans. You can compare live configurations, so different anchors. You can see how they compare, what has changed between them. A future use case that we're working on is that we use these delta differences to send notifications so that applications can subscribe to notifications that are being detected this way. As I mentioned earlier, the CPS is designed to store any young model data. So this is all about CM data, but it can be anything. And in our demos and our tests where we often compare bookstores to make the point, you can actually store any data and query any data. The output of the tool, the team that designed it put a lot of effort in making sure they had a good output format. So they looked at different IETF standards like RFC 6902 for a JSON patch and RFC 9144 for comparing NMDA data stores. And they kind of took the best of both. And what you'll see is a patch-like structure where you maybe have add some data, remove, or update, and I will demo all of these during the demo. So as I mentioned before, Deutsche Telekom are hoping to use this CPS Delta feature in production next year. So this is where we will start the demo. So I'll start with the Swagger UI. So we are kind of, how do you say, we are documentation first. I can't think of the term now. We define our interface first and we generate the code format. So it's all driven by Swagger. So if we link to our Swagger document, I need to scroll down a little bit here. You should see the new endpoints. So this is the Delta feature. This was the thing I had planned to demo. And only literally in the last week, they've extended the feature a little bit. And I will demo that as well, where they, instead of comparing two anchors, we're going to compare data stored in the system with data that you upload. So you don't have to have both of them already in the system. Yeah, go ahead.
Doing Delta just means so just creating a database and living in the database, you're making updates.
No, we're comparing what's in the database in different instances of different anchors. Yeah, so I'm saying anchors now in NCP, you might be talking about nodes or functions. So you're comparing two instances and seeing the differences. Yeah, no. Now the output could be used to do updates, but at the moment that's not really in place yet, or not planned even. So at the moment it's just for reporting purposes. So let me switch to my Postman collection now. And hopefully then it will start making a lot more sense. Now I first want to show a little bit of these core concepts again. So the first thing I'm going to do is create a data space. You see the URL. Is this big enough to read? I can make it a little bit bigger. Or is it okay for everybody? Oh, okay. Okay. I'll go to, that's a bit too. The one thing that always frustrates me when I'm doing demos that I suddenly have a small screen and you don't have three screens where you can see loads of things. So I hope this works for you guys. So I'm creating a data space with the name LFN Demo here. I should have explained, I've started, everything is running in Docker containers on my laptop at the moment. So I've deployed the whole CPS. And I'm just gonna connect to the REST interface using Postman. So I'm getting a 201 here, so it has successfully created the data space LNF demo. The next thing I'm going to do, but I'm going to switch over for 1 second. So maybe to explain as well, I should have it ready in my IntelliJ. Yeah, a bit hard to see my tabs. There's too much stuff over my screen here. Can I move this? Oh, I can X out of this. Yeah, that's okay. So you can see here on the left, this is a very simple bookstore model. Typically, and you probably all know that data is usually described with multiple models. So a model can import another model. So you actually see the import here. So there's another thing called bookstore types here. That's simply, it's just for demo purposes. It describes a type inside the bookstore model, and just so that we can show that we can work with multiple modules that together form one schema set. So those are the actual modules in this case. And then in Postman, what we have to do for the request, we have to create a zip file to combine these files and we'll upload them. So we're creating here if I go back to the parameters. So we're creating in the URL, you can see in the data space LNF demo, I'm going to create a schema set. I'm going to give the name bookstore model, and I've attached a zip file that that contains the file set I've just shown to you. So hopefully when I press send, we'll get it created. So that worked okay. So now I'm going to create two. I always think of it about, I'm going to dig two holes where I'm going to plant trees. So I'm going to create two anchors. So again, pretty much the same format. We have a data space. And typically when we plant or when we create a hole, we're actually putting a label beside it. We're going to create this kind of tree here. And that's the only data it will accept. So that's for validation purposes. So I'm going to say in both of these cases, in both of these anchors, I'm going to expect something that describes a bookstore. So I'm going to create the first one. We get a tool one created. Going over to the second one, just a different name. Apart from that, everything is the same. So at the moment, I just have holes in the ground. I don't have data yet. So the next step is to actually post some data. So that's a standard post command. You see the similar URL. So we're going to the data space. It's a bit small now. You can't see it. I think if I click on this, yeah, you can see we're in the LNF Demo data space. We're in the bookstore one anchor, and I'm now creating the nodes. I'm now using the nodes URL, and I'm starting from the root. I could upload some data further down the tree. So the X path is basically the root of the tree. And here you can see a simple bookstore model with some data. I'm going to upload that. So that's our first tree planted. So I have a second one here with exactly the same data. Again, so that's successfully created. So that's pretty much the setup finished now. Now let's do some basic queries. So a very simple get command would be to, again, the URL looks familiar. So we see the data space, we see the anchor bookstore one, and we're using the XPath function again to say where we start reading, and we now also have this descendants option to define how far down the tree we want to read. And we're going to read all the data now, so we're going to go as far as the tree descends or exists. So if I execute that, I need to scroll this up a little bit. So there's the data, pretty much exactly what I just posted there a minute ago. Nothing too exciting about that. That's a simple get command. A little bit more exciting maybe. So, and we have loads of variations of this. So for the people that are working with CPS, they might be aware we have this concept of what we call a CPS path, which is based on XPath. So XPath is a well-defined kind of query language to define to read this kind of data, XML and young model data. So in this case, I'm using a function here. You see the double slash here. That basically means I don't care what's in front of it. I want to find any branch that has the name books. And in this case, I have a condition. This is not a key field. This is just any attribute. So I want to find any book where the price is greater than 20. So this is a very simple example of a CPS path query. The reason we didn't call it XPath is because XPath has like 1 million capabilities, and CPS path doesn't quite have 1 million yet. I need 1 million contributors to probably get to the 1 million capabilities that XPath has, but it has the core things. And we've had users, and they've asked for specific, and I think Deutsche Telekom are again, they're looking at expanding this functionality. Okay, so if I run this, I should see exactly 2 books, if I remember correctly. So bookstore 2, they kind of come out in random order. Bookstore 2 has 1 book here about Linux that has a price of 39. And then because the data is identical in the other one, I get the same book, again with the same price. So that's just a quick kind of recap of the core concepts, what you can do with CPS. And like I said, you can treat this for any data. You might just have a simple application store some data. Where you don't have to model the database. All you need to do is describe it with a young model, and you get all these capabilities more or less for free. Okay, so now let's go to the delta function. So if I run it first here, and I already ran it last time, you could see the output already. So what the delta feature returns is this report is basically a list of patches. So it's a list, so it's an array. Because I have 2 identical trees at the moment, I simply get an empty list back. Okay, so let's make some changes. Now, there's other ways of updating the data, but the quickest way for me to demo is I'm just going to delete. Oh, I need to be careful here because I have a new step here, so I almost clicked on the wrong one there. So I'm going to delete the second. No, still not at the right one. Now I'm at the right one. So I'm going to delete the second data node, just the data, and I'm going to modify the data somewhat. So I'm going to do I'm going to change the price here. So I'm going to change the price of this one to 21. And I'm going to send that. It's successfully created. I'm going to run this query again first. So remember the query I ran earlier where I look for anything that's has a price greater than 20. So on bookstore 2, Oh, I need to scroll here. In bookstore 2, it's still just that book about Linux. And in bookstore 1, we have the Matilda book now as well that has a price greater. But this is not a great way of finding differences, of course. This is way too slow and still, it's not really highlighting the differences. So let's now run the delta report. So compare the anchors again. So what we'll see now is the array, but now we have something in the array. We have one, and they call them actions. So in this case, it's an update action. We see the path of the data that has changed, and we see the source and the target data. So actually, maybe I didn't really show this in the URL. We had the normal start of the URL, which points to bookstore 1 anchor, and then we have a target anchor. So this is the one we want to compare it with. So I told it to compare it with anchor 2 there. Similar options, we can say where to start comparing, and we can decide how deep we go in the tree for comparing. And in this case, I just compared the whole tree. So when I ran that, it told me that it found one particular attribute that in the source has a price of 20 and in the target has a price of 21. So it only lists the path to the thing that has changed and only the attribute has changed. So it's a kind of neat report just to see what has changed. Now let me do a few more changes. So if I go back, I'm going to delete this node again, and then modify it a little bit more. Now let me delete that whole Matilda book. Okay, and send that successfully. Run the delta between anchors again. So now I see oh, let me just, I hope it kind of fits. I think you can see it there. So we have one action again, which is remove. It gives me the path to the thing that has removed, but now it gives me all the data. If there was children, those will also be included. So this is a very clear view of what has changed. Okay, so then I'll do my third use case. Let me recreate the second one again with another small change. So I'm gonna insert a new book. I'm just gonna use copy and paste because I'm not really good at typing JSON on the fly. So this is a book. It's all about CPS. It's written by me in this year. I don't think I'm going to charge any money for it. I don't think it will sell very well. So let me send that. And then do the delta report again. So what we see now, and I think I can just click here to collapse it. Yeah, here. I can actually see two actions now. So the remove action is still there. Before this, yeah, I'll do it like this. So the remove action that the book Matilda, because I didn't put that one back, it's still removed. But we have a second action now in our array that we have a new book added, and you can see all the details there. So that actually completes this is what we have prepared. And as I said, the feature I'm going to show now is about to be delivered. It's not quite delivered yet, the cleaning of the code a little bit, but I have a copy of the patch running here. I'm going to show you where we can also, instead of comparing two anchors, so I need to click this one now. The format is a little bit different here. So this URL, so you might let me show that first. And to be honest, we're still a little bit thinking about the name. I'm not so happy with the name yet, but the feature does exactly what we wanted to do. So we're referring to bookstore 1 in this case, and we have this. So the URL is now called delta by payload. So there's no other, I'm not pointing to another anchor, but instead in the form, I have this JSON data. And by the way, you can also, if the data is not compliant with exactly the same model, because any data that we upload will be verified against the young model. If there was a different model, I can attach a zip file again with the model that describes this data, and it's still able to compare the common stuff. But in this case, the data is compatible. Now it's gone very small here now. I'm going to try to change because this was a copy of the data. Apologies, the screen is very small now, and I'm not sure if I can get to where I want to be. No. Oh, no, it seems to work. I just need to scroll to the right and not use the down key. So you can see here it's the same data again, but And if I do that, I get no differences. Actually, I might have changed it before. No, it's price 20, yeah. So let me put in price 25 here and send this up. So in this case, I'm sending the data that I want to compare to. So this could be, you know, a day zero configuration in that use case for CM data again. So let me send that, and then hopefully, yeah. So what I see now is very much as that very first use case that I showed when I was just changing the price of in the second anchor. But in this case, it's comparing with the uploaded data. So you can, that's actually the target data. So very much the same functionality, just I don't have to have the system already or what I want to compare with. So you don't have to store it in the system. You can just keep it separately for comparison purposes. Any questions on that? Because that more or less completes the Delta feature. Shankar.
The network will be more like this is the state comparing, but is it consistent?
Yeah, maybe you had an optimal state or a begin state you want to compare it with, and then you get the differences with that, which I think is a more likely scenario than that you store the original one in the same data space, because it doesn't seem to write. The whole idea is with the data space, they're kind of a common, how do you say, common purpose. So to me, it wouldn't make much sense to have your day zero, your optimal configuration in the same data space as your live one or your current one. So that's why that second feature makes a lot of sense, I think. Yeah.
It does make sense because sometimes you're going to make a change in the network and before that you just verify that it is consistent with what's already in the database. You want to do a quick check.
Yeah. But like I said, they don't, and I say in CM, they typically probably not both in the database. So the whole idea is you can do a planned one and compare it with your planned one without having it in the database first. Yep.
Yes. I have a concept of timestamps for
not here. It does have, we have this, we send notifications now. We had CPS temporal, but that has been deprecated, as you know, which was actually storing all changes with timestamps. We're still using pretty much the same mechanism to now send notifications if anything changes. But this feature does not have a timestamp. No.
all changes, but if the action did a post below modified, so the timestamp, and when you put a delta, there are three differences you will know.
Yeah.
When they're made. But that's
it's not stored in the core database at the moment. So we're looking at reintroducing something like CPS temporal, but the problem with CPS temporal, it was very crude, and it actually had huge performance impact because it was always sending all the data with all the timestamps, and it really slowed down everything. So we're working on a more, well, we have plans for a much more granular solution where you specifically say maybe on an anchor level and maybe on only specific paths you want to keep track of changes and store the timestamps. And then I can see if that's done. If we store that information, we can have notifications and we can have this Delta feature using those timestamps. That would be well possible, yeah. Carmel? Sorry, maybe, can you use the microphone maybe? Thank you. Yeah, I don't think it's switched on.
We're talking about the delta. Can we have the delta based on the version? Let's say we have two young models. Let's say take 3GPP, run young models, version 1, version 2, and then get the delta between these two versions.
That should be doable.
Yeah.
Interesting idea, yeah.
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 Because if you see the, let's say core or 3GPP run slicing young models.
So if the young model could be stored as young data, which I think it can be, then you can theoretically do that. Yes, I think that should be well possible. Yeah. Again, an interesting idea.
Yeah. Second question, I mean, this is good. I mean, I was just thinking the concept for me is similar to what GraphQL is doing also. Is there a plan, I mean, to use GraphQL instead of REST, HTTP REST?
No, I'm not familiar with GraphQL either, so
okay.
we can talk about that maybe outside. Okay, thank you very much. Okay, I'll continue with my, go back to my slides. I need to see my slide to remember what's next. Oh, wrong window. Okay, so we've done all of that. So yes, now we'll get on to performance. So people that are following us and maybe at previous conferences, we know in November I also did a presentation on performance improvements. Fact is, performance is a really big part of what we're doing the last couple of months. So we're constantly improving this, and again in New Delhi where we made huge improvements. So that's why we're going to come back to this. And I also want to show a little bit how we test it now, because performance is so important for us. I want to highlight both of those. So these are some of our main improvements. So one of the first thing we did in this release was to enable Hibernate batching. We had our own kind of way of batching in code, but it turned out that Hibernate batching was complementary to that, and specifically saving data to the database, which we got some complaints from the community that saving data, writing data was particularly slow. So enabling Hibernate batching doubled the performance of that. In the test column there, you can see references to specific tests that we have for these improvements, and that I'm going to demo later. The second one actually was quite interesting. So when we looked at our update operations, again, we saw they were very slow, and we looked at the database logs and we realized that under the hood, there was a lot of updates happening that actually didn't need to happen, that shouldn't have happened. So what turned out was happening was that in the Postgres database specifically, we stored the leaves, so the attributes, using I think it's called a JSON-B object, which is just a string with all the JSON. But when it's stored and it's retrieved, the order of these attributes is not guaranteed, and they don't really matter for a functional point of view because there is no order in attributes, but they matter when the algorithms or when Java was comparing it. So because the order might have changed in a piece of Java code, the system thought, or the Postgres database thought something has changed and it was doing an unnecessary update. And this was then also exacerbated by the fact that JSON-B is kind of optimized, so it's kind of a condensed JSON format, whereas in Java we kind of typically use a bit more readable JSON format. And again, because of the difference in white space, the system thought there were updates that weren't there. So by putting in what we call normalization, making sure that when they were comparing them, we're using the same order and we're using the same format, we're able to prevent a lot of unnecessary updates. And again, that increased performance in the typical update use case, end-to-end use cases, by a factor 2. So these first two are CPS core specific updates, well, I should say generic, to apply to anything. The next improvement is very much about NCP, which is kind of a specialization of CPS for CM management. So we had a use case in NCP to register 20,000 CM handles, which had a very critical performance requirement. And it was, again, slower than we wanted it to be or than it should be. So yes, okay, I was kind of forgetting what this was about. This was about, and I mentioned before, the young model. Any data gets stored, gets parsed, and gets basically validated using an ODL parser. And when we were doing the 20,000 CM handles, we were actually doing one at a time. Although we were doing loads of operations in batches of hundreds, the actual parsing of the data, we thought it wouldn't matter that much. We did at one at a time, but it turned out we could also do that in batches. So give the parser 100 at a time and validate them, because typically it would all be okay anyway. Only when one fails, you have to go back and do one at a time to see which one has failed, but that almost never happens. So enabling batching at that level as well increased that use case by a factor 4, which is very significant. You might remember during the demo, I showed you this query where I was looking for books that had a value of greater than 20. For our CPS path queries, we kind of had one algorithm. In that particular query that I showed, there was no prefix, so I didn't care what the parent of the book was. So I didn't care. It could be, could be a different model that has some different kind of parent, and it would still work. And it is kind of handy for the user to search for that. But in actual use cases, we often have the whole path. We often know what the parent is all the way to the root, and we might just have a simple condition. But we're using the same algorithm to resolve both, and that kind of was unnecessary. And we realized by checking whether we had the full path, which is actually relatively easy to do, we could use a slightly different algorithm, and that again typically sped up these kind of queries to a factor of 5 or 10, which had a huge effect on some of the overall use cases. Kind of unrelated to database or Java code, and it was kind of a side effect. You might remember Byung mentioned it in his overview that CPS implemented service mesh quite a while ago. And before that, we were using Spring Security. But because of service mesh, we simply didn't need Spring Security anymore. And when we're doing some analysis of some slow requests or to see where the data was being spent, we realized there was a huge overhead in each REST request, which was due to Spring Security, which was simply redundant. So by removing the Spring Security, we reduced that overhead from 100 milliseconds to 10 milliseconds. So especially in operations that we did many small operations that maybe only took a few milliseconds, by removing this overhead, again, a many-fold improvement in the overall performance. Okay, so as I mentioned earlier, it's all good and well to talk about these improvements, and yeah, how do I know these figures? For instance, we kind of one of the things we did in CPS is reusing this POC and Groovy unit test framework that I talked about earlier, that has this nice format with given, when, then, and where. We also started using that to do not so much unit functional tests, but to write kind of what we actually call micro benchmark now. So you take a small a method to a small operation, and you do that either many times or you do it with a large data set, and then you measure how long that takes. And it's also not really unit test, because another thing we do here, we actually use the Spring Boot test framework where we inject test containers. So we inject Postgres, so we're working against a real instance of Postgres or a Kafka test container. It also gives us the advantage to kind of, I always call it semi-integration test, where you test different modules together. So the whole idea is you write a specific test case or something. Maybe you get a bug, something is not fast enough, and you could do test-driven again first. And actually we've done that, where we write a test first that kind of shows, well, it's now so slow. Then we work on the improvement. We keep running that test until we get happy with the result, and then that's the main point. Sorry, I'll get back to that in a second. Before I get to mention, these are kind of these semi-integration tests, I call them. They're really powerful. The really nice thing is you can run them in the IDE. So it's not a specific job you have to wait on maybe 20 minutes to run and go back. No, you can run them now, not in fractions of seconds like a typical unit test, but still in under a minute. And you'll see that during the demo. You can just rerun them as you keep improving, and you're running them as long as you keep running in the same environment. You can compare, so you have an improvement. So whether it's your laptop or another environment doesn't really matter. You can see the improvement, and I'll show again examples of that in a minute. Okay, so how this look like, and I'm going to show you this in IntelliJ, it'll be more interesting. So this is just a test base class. You can see here at the top, you can see I should use these kind of pointers, don't I? At the pointer option, laser thingy. There you go, yeah. So you can see here, this is the kind of Spring Boot boilerplate. There should be an annotation here, yeah, Spring Boot test. And you can see the injection there of the test containers. So this is the base test class that we use for almost every integration test, or these acceptance tests, we call them actually now, to separate them from the classical CSIT test, where we use the injection. And then this is, yeah, but I'm going to show you live now so this is a live demo. For people that want to look this up and be more interested in the details of the code, these link to the actual repo, the actual methods that I'm testing it. So if you're interested in seeing how you actually code something like this, you can use these links and look them up. Now, where's my IntelliJ gone? That's there. So this was the first improvement I mentioned, and I should have mentioned, actually, it was actually Wipro that had this, and I think this is some kind of router. Maybe some of you are more familiar with this Open Road M. And basically, with huge data sets, much bigger than this bookstore model that we used before. So they this is how they discovered one of the right issues. So we used that data that was used in the community to write tests around it. So this test, and let me start running it actually, and then because it will actually take a minute or so to run. because it will start a Spring Boot environment. It will deploy those containers. Things like Hazelcast are being started up in the background. So you can see it all running there. Typically takes about 30 seconds to a minute. Actually, yesterday I found something, I discovered something interesting. It's a lot slower when I plug out my laptop. So that's why I was making sure I had power. So the laptop has something built in as well that it's kind of more, I don't know, doesn't use as many resources and gets a bit slower when it's not plugged in. Okay, so what I was going to show here, so this is the structure of the test. So you can see there, this goes back to the core concept. So I'm creating an anchor. I'm adding some data, well, I'm adding some data. And then this is the method I want to test. So you see the save data here. And then I have some conditions. I'll explain this bit as now as well. We have this class, this resource meter here. So this is our own class that kind of, we used to just have a stopwatch, but now we're also interested, although it didn't work out so well, to try to find out how much memory certain operations used, but that turned work so well. We kind of got an idea from it, but for this demo, I kind of disabled it again. But the resource meter does actually try to keep track of memory use as well. And then for the people that are not so familiar with Spock and Groovy, you see here basically it's running this test with several options here. And you see this warm-up here that I'll explain in a minute and why we need to do this. And then I'm running this particular operations with 50, 100, and 200 nodes. And then you can see here. And yesterday, when I was trying to rehearse this, sitting in one of the meetings, just kind of make sure it all still works, all these tests started failing. And then I eventually found out it was because I didn't have the power plugged in. So there you go. Anyway, they're passing now, luckily. So I'll move on to the second test. So this is the update performance test. This test works slightly different. Again, I'll start it first, so I can explain how it works while it's running. So in this particular case, we actually have a setup. In reality, this class actually has several test methods, which I think I deleted some of them for the purposes of the demo. But in this particular case, the first test access up a large amount of data that I run my subsequent test on. So you can there again see creating the anchor and saving the data, but I'm not interested in this actually working. I'm just making sure that the data gets set up correctly. And then this is the actual test I'm interested in, and there's loads of variations. So this is kind of a mix of a functional and a performance test, because there's many ways of updating here. So you see loads of variations. Now make sure I see the test result. Well, let this come up. Yeah, it's not quite started yet. So in this case, I'm having multiple scenarios. And again, this is so easy to do in Groovy and Spock. You can just very quickly make all these kind of combinations and have different variations. So I'm releasing, this is basically inserting 100 new ones. I changed the figures here because it would be a bit slow for demo purposes here. So it's not really doing 100 at the moment, but you get the idea. Replacing 100 existing one with the same data. That's actually enough. That's why we had some of the issues when it was doing unnecessary updates. So all these variations are being tested here, and they're all being timed to see how they perform. And luckily, again, they're all actually going correctly. No, I'll show that as part of the last one. So I'll do one more demo of these. Oh, okay, that's my tab. And this is really the type of test that we use for benchmarking. The other ones were more kind of functional and for improvements. And I'll show you what I mean with the difference in a second. Sorry, I think. Yeah, this one I need to run. Sorry. And this one I can run on its own. Doesn't depend on any previous test. So this is a good example of a benchmark test. So I'm testing a simple operation. Very much like that query I did at the very beginning. So this is for a specific model in NCP, but it doesn't really matter. It could be any model. And this is just proving how fast this query is. I'm doing it 100 times, because if something is really fast, you do it only once. It's not really, you don't really get a reproducible figure. So that's why we're doing this like 100 times. And then again, we kind of record, in this case, the average, and we check that how fast the average is. Now, if I did start it correctly, it should be running shortly. And I just want to show you something in the output when this is done. Still starting up. Actually, if that was a lot faster, then these tests would actually be relatively fast. It's mainly setting up the environment for all of these tests. That takes most of the time. Yeah, unfortunately, this one fails. At least that gives you the idea that it's real and not faking everything. I probably should have adjusted this figure. I'm not quite sure. Pretty sure it ran for me earlier and it did pass. Anyway, oh, now I can't show my output, can I? Oh, what now? Let me run it one more time. No, that's, no, I'm gonna go back to, what time are we? No, actually, I'm gonna move on. What I wanted to show you is that all these tests in the console, they output in a kind of a nice fixed format, the time, so the name of the test and then the response time. And what we do is we extract so the output goes to console, and then we have scripts running in CI to extract that information from all those benchmark stacks, and that's where I want to go next. So if I think I need to go back to my slides now. So yeah, that's the 3 tests I ran there. Oh yeah, but before we go there, the warm-up effect. So why had I a test there and I had this warm-up effect? I'm not into race cars myself, but I think most people know that, at races, they warm up the cars first, don't they? Because they go better. Well, you run something for the first time, and I think developers know that too. The first time you run a certain method or something, it's not as fast as the second time. But it's actually much more complicated than that, and I didn't realize that. So there's a few things going on. So Java has this concept of just-in-time compilation. So most classes get loaded lazily. So until the class is actually being used, that's the first time it will interpret the class and have kind of a low level, or what's called like a native code version of it. And of course, that makes the first call slower. It then goes into a cache, and subsequent calls should be faster. Now, apparently since before Java 8, there was an option called tiered compilation in the JVM. But since Java 8, that has become the default. It's enabled by default. And there's actually 3 stages now of compilation. So this first interpreted version of the codes gets stored in this cache with profiling. And what Java does is it will monitor the use of this class and the performance. And then depending on how much it will use, it will create another more aggressively performant version of it. Don't ask me the details. There's some links here in building here that describe it in more detail. But at a high level, what it does is it creates a better version of it, still with profiling. This is called C1 client compiler. And eventually, but you're talking about running it tens of thousands of times, it will go to this most optimized version, which is fast again, and then it won't have profiling anymore. I believe it can take it out of it again if it's not being used anymore. But anyway, there's interesting stuff to read up there. And in one of these articles, you see a graph, and that graph looked exactly to what we were seeing in reality. So this is that query I showed you in the last test. So the very first time you run it, or the very first time you run it, it's actually in the order of 12 milliseconds. Then if you keep running it, it quickly drops to about 8. And then eventually, after something like 9,000 runs, it drops to about 4 milliseconds, and then it stays stable. And this is the effect of that Java doing this optimization. So if you do performance measurements and you measure it and you want to improve things, you have to have this in your head. And I know a lot of tests where a lot of CI, they do things only once. That might be not a real, because a customer might be running something for days and it's always live, and the code will be optimized for what they're doing. But the CI test never took that into account. So now you might have discussions with your stakeholders. Is it acceptable that it takes 3 days to achieve this? I don't know. But you have to be aware that if you measure performance, that these things are all, and it's not very exact or always the same. You need to know, you need to know the background of the Java optimization. The Java compiler has gone very clever. Yeah, sorry.
I mean, I see that you are using Java 20, right? I mean, just wondering if you have tested the performance with the GraalVM native compilation.
No, we haven't. I know
Yeah.
I've been to talks talking about that. Yeah, it'd be interesting to. But at the moment, we're sticking with what we have.
Yeah.
I think if it comes,
It
yeah, go
came
ahead.
September 20 last year, Java 21, which support GraalVM native compilation in Spring Boot 3. I think we should, from performance point of view, compare it to cloud native build packs is much better.
Okay. Yeah, no, definitely be interested in trying to look at that. At the moment, we've been mainly looking at just optimizing what we have at the moment. And I think when especially if we get to critical points where we don't see any easy gains, but then we definitely look and anyway, we should look at
Yeah,
that.
because you don't need a warm up phase.
Yeah. Thanks for that, Kamal. Okay, so then I'll finish up on the monitoring. So what you just saw there and those results. So what we do is we actually run these micro benchmarks every 2 hours now. We started with doing it only once a day, but we realized that didn't really work, as in you only have one measurement every day. And if something happened yesterday which reduced your performance, you wouldn't really see it. So we run it now every 2 hours. We use a Jenkins plugin to store and graph the results. So it looks something like that. We actually have 30 graphs. So every day during our stand-up, we look at these graphs and make sure that there is no significant drop. You see a bit of a trough here but again, that's just reality. That's where all the tests for some reason didn't start and we didn't get any results. So that's kind of part of daily life with these tests, but typically it's not a big issue. You can see that only won't have happened once, and then for days it was good again. And there's usually some kind of weird intermittent issue that sometimes happens. So it's mainly used for watching out for degradation, but also again, when you work on a performance improvement, you can look at these graphs and make sure that you see an effect, and maybe it affects other use cases that you didn't realize. So that's what the performance monitoring is about. So what are all the lessons learned with this performance monitoring? I think I mentioned most of these during my chat. So you need to have a reasonable size test. If you have a test that runs in a few nanoseconds, now that's no good. You just crank up the data, crank up the amounts of times you run it till you get, I think you need to get in the order of tens or hundreds of milliseconds to get something repeatable. We actually found, and this might be controversial, we had all this stuff running in cloud environments. But we realized that the cloud environments, it was especially depending on the time of day, you didn't get the same results. So we a couple of months ago, we changed to a physical environment and we got much more repeatable results. So it didn't matter, the time of day didn't matter. So even in a cloud environment, there can be other outside factors. I don't fully understand clouds and how they all work, but at the end of the day, it's running on somebody's hardware. So obviously there is some other factors there that might affect the performance of your cloud, even though you should have the same resources. I just mentioned that, yeah, running every 2 hours. Again, I had to change a lot of these figures because I have a Windows machine. Most of my team have Linux machine. If they run it locally, for most use cases, they get actually better. There are some use cases where Windows, interesting enough, is faster. I don't know why. I don't really care. All I care about is that I get consistent results and I can compare my test results. So of course, laptop or server makes a difference. Funny enough, the laptops are often better than a server. They're quite powerful, and if that's the only thing they're doing, you get faster results. But again, it's only about consistency. And I already mentioned the virtual versus physical. And then the main lesson was that warm-up effect that I explained a little bit more detail earlier. I think that's no, that didn't quite complete sorry, this was the last edition. We are actually constantly evolving. So we're now looking at case 6 in more kind of end-to-end tests, probably replacing the CSRT. And again, that gives you more things like concurrency, concurrent users, and nice reporting as well. So we're experimenting with that at the moment. So we have a POC in progress on that. That's it, yeah. So feel free to reach out to me, or if you have any more questions now. Thank you very much. No more questions? Okay. I'll stop the recording. Sorry, I only gave you 7 minutes.